Here is our distillation column. Note you can see the 8 trays. Here is the reboiler. It can hold nearly 10 liters of liquid. The drain from the reboiler through the heat exchanger to the bottom's receiving vessel. That is the heat exchanger that exchanges heat with the feed stream. The 2 sections of 4 trays each, additional section that reaches all the way up to the condenser, a reflux drum, the reflux valve in the back, the distillate collection column vessel. Here is the cooling water where you can set the flow rate. Cooling water comes in from the ceiling cooling water taps and return. There is the manometer that measures the pressure drop from just above tray 1 to just below tray 8. That is the distillate receiving vessel, and the green is the reflux valve. That is the feed pump, the back of it. Right. Start total reflux operation by filling the reboiler. You can see the back of the reboiler here being filled. Fill the feed tank to get it ready for part 2 of the experiment. Turn on the cooling water in the ceiling and then adjust the flow rate with the flow meter. Okay. You turn on the controller and the software, and this is the screen that you see. Record the initial tray temperatures before any heating has occurred, so you can see what the steady state temperature measurements are. They should all be approximately the same. Adjust the reboiler power to 2 kilowatts to heat up the feed. It takes about 20 minutes to heat up all the trays. We want to make sure we don't overheat the column. So when the middle tray heats up to about 78, where ethanol is boiling, turn the power down to 5 kilowatts, and then we let the rest of the column heat up at the initial 5 kilowatt power setting. 0.5 kilowatts, excuse me. When we see reflux, we start to record data. So we see the first drip of reflux dripping into the reflux drum. This is the time to turn on data recording. When temperature profile reaches steady state, we start recording data. Okay. Pressure drop, we open V6 and then V7, and then we close them, and then we can read the manometer, which is full of water. It's a water manometer. Then we take a look at the foaming observation. And you can see here the 2 black trays. That's tray 5 at the top and tray 6 at the bottom. And you can see the foaming going up a little bit on one side of the tray. This is pretty mild foaming. Now this foaming is the gas phase going through the liquid phase and expanding the liquid phase. Now imagine further when we have a lot more vapor flow that the foam reaches all the way up to the tray 5 from tray 6. And then the liquid and the vapor will have a tough time separating completely, so that some of the liquid will get carried up to tray 5 and go up from there. And this would be a point of entrainment. Now we need to measure the specific gravity of our samples that we took. We want to check the temperature and make sure it's well mixed. We want to use the appropriate hydrometer. And while we're waiting for the temperature to come down to the appropriate temperature for our specific gravity data, we can cool it in ice and make sure it's covered with parafilm so the ethanol does not evaporate. All right. Now we're continuing on with continuous operation. We're going to put the tubing from the feed tank through the pump, the rotary pump, close it, and start feed flow. Now we want to make sure that the feed is flowing. So you can see that this tubing is the feed tubing coming through the pre-heat exchanger. And you can see that there's some bubbles going through that tubing, but you can see that they're moving up and into the column, so feed is flowing well. To drain all material out of the bottoms and the distillate, and then collect steady state sample for an appropriate enough amount of time till we have enough. And then we will collect that sample from the bottoms and from the distillate. And we can then measure the specific gravity of these two and compare it with our results that we are expecting. During turtle reflux, we need to measure the boil-up rate. And this is a little bit tricky, but we can measure the amount of condensate coming through the condenser that is on its way back as reflux. But before it goes into the reflux line, which you can see with the little piece of red tape on it, we are going to drain the material that comes out of the condenser.
You can see
so it's very important to keep that steady.
Yes. You can see the job, right?
Yes.
By measuring only what is coming out of the condenser and not draining what is backflowing out of the distillation column, we can get a fairly accurate measurement of the molar flow rate of vapor up the column.